Adapting the Poisson distribution for different intervals. In a Poisson distribution, events occur at a constant rate, so the mean average number of events in a given interval is proportional to that interval. What it means is that, for example, you are given, for example, there are, for example, 5 accidents per, for example, 30 seconds. So here the lambda is given for 30 seconds. But in the questions, you're supposed to find probability, for example, for 1 minute. So we know that 1 minute is actually twice 30 seconds. So the time, the interval, is multiplied by 2. So 5, which is your parameter, your lambda, is multiplied by 2 as well. So it will become twice for 1 minute. Let's see some examples. Example number 1, people arrive at random and independently at a post office at an average rate of 2 people every 5 minutes. Work out the probability of first part. The initial lambda is equal to 2 per actually 5 minutes. Now, for the first part, it says 3 people arriving in a 10-minute period. So it was 5 minutes. So new lambda will be twice because it is the duration, the interval has become twice. So lambda will be twice as well. So x will be have Poisson distribution with 4 as the lambda because twice the initial one, which is defined for 5 minutes. So you are supposed to find probability of x is equal to 3. So considering 4 as your lambda, it will be e to the power of negative 4, 4 to the power of 3 over 3 factorial, which is 0.195. Now second part, more than 4 people arriving in a half-hour period. Half-hour period means 30 minutes. So it is 30 minutes is 6 times 5 minutes. So it is also multiplied by 6. So new lambda will be, x will have Poisson distribution with 12 as the lambda. So more than 4. So probability of x greater than 4 will be equal to 1 minus probability of x less or equal to 4. Now, so it will be 1 minus probability of x is equal to 0 or x is equal to 1 or x equal to 2 or 3 or x is 4. Now brackets closed. Now it will be 1 minus lambda is 12 e to the power of negative 12, then 12 to the power of 0 over 0 factorial plus e to the power of minus 12, 12 to the power of 1 over 1 factorial e to the power of minus 12, 12 to the power of 2 over 2 factorial plus e to the power of minus 12, 12 to the power of 3 over 3 factorial, and the last one e to the power of minus 12, 12 to the power of 4 over 4 factorial, which will be equal to, at the end, 0.992. Part C, 5 people arriving in a 4-minute period. So as I said, they are proportional to each other. So for 5 minutes, lambda was 2. Now for 4 minutes, the new lambda will be 2 times 4, 8 over 5, which is 1.6. So part C, probability of 5 people, x is equal to 5, and your lambda is 1.6. So e to the power of negative 1.6, it was 5, sorry, 1.6 to the power of 5 over 5 factorial, which will be 0.0176. And the last part, part D, one person arriving in a 1 minute period. 1 minute period is 1/5 of actually 5 minutes. So your lambda will become 1/5. Your lambda was 2. So 2 times 1 over 5 will be equal to 0.4. So your x has Poisson distribution with 0.4 as the lambda. So probability of x is equal to, it says 1%, is equal to e to the power of negative 0.4, and then 0.4 lambda to the power of r, which is 1 over 1 factorial, giving you an answer of 0.268.